Good afternoon, everyone. Before we begin, please confirm that you can hear me and see the slides clearly by just typing yes in the chat window. Also, we would like you to introduce yourself, your name, your designation, company, and the country you are based in. It's a pleasure to see an international audience of people from all industries and backgrounds. Good to see you all. Great. We are receiving your confirmations. Thanks for confirming. I would like to thank you all for registering and taking time out on a Sunday to learn about fundamentals of conduction, SIL classification, and SIL verification in accordance with IEC 61508 and IEC 61511 by using VAIL-PHA SIL software. My name is 𝐒𝐈𝐋 𝐂𝐿𝐴, and I will be your introductory speaker for today. It's a pleasure to host this webinar for you. Just for your information, this is our 80th webinar in the series of technical webinars we are conducting. As a practice, we are conducting one webinar every month. Please follow us on LinkedIn, YouTube, Twitter to make sure to check our website for the latest updates. Today, we have an experienced panel of speakers. I am with my colleague, Mr. 𝐻𝐴𝐵𝐻𝐼𝐿𝐴, Managing Director, Principal Integrity and Safety Consultant, Madam Mubina Khatoon, Director, Engineering Services, and Mr. Anthony James Williams, General Manager, Global Sales. Moving forward, during this webinar, we would encourage you to keep asking questions to clear your doubts. We would definitely like your engagement on this topic. You can type your questions in question and answer window, and we would either answer it in question and answer window, or we will answer it live. We will try our best to answer as much questions as possible during this session, and we will have a detailed question and answer session at the end of the topic. Still, if your question is left unaddressed, please accept our apologies, because we have a high volume of questions that we usually receive, so we have to be selective. Furthermore, we will also be issuing participation certificates to all those who have attended at least 80% of the webinar and have participated in the question and answer session. Since this is a very detailed and thorough topic that we have chosen for today, so we will just be touching the practical aspects of today's topic. During this webinar, you will go through Velosi introduction, why safety integrity level SIL is important, what is SIL and SIL determination techniques, test interval calculation and SIL verification, development of safety requirement specification, SRS and STR calculation, MTBS, MTTR, and VAIL-PHA SIL report. And as discussed, at the end, we will have a detailed question and answer session to answer any doubts left with you. Before we begin, although most of us are in the comfort zone of our homes, we should be aware of emergency exits. We should keep a safe distance, and we should generally take care of ourselves and people around us. Now, I'll hand it over to Mr. 𝐻𝐴𝐵𝐻𝐼𝐿𝐴, who will start with today's presentation.
Good day and Assalamu alaikum, everyone. We know it's Sunday. It's a holiday in many countries. But still there are working time is also there, like in Saudi Arabia, Qatar, and Middle East, other countries. Today's topic is introduction to SIL. SIL is mainly related to process safety, and it is an important topic nowadays since the inception of IEC 61508 and IEC 61511. And as you know, for every petrochemical industry, upstream, downstream, hydrocarbon or non-hydrocarbon, there is ESD system as a part and parcel of the process control system, or BPCS, along with. And the reliability of ESD system is determined and maintained with the concept of SIL and SIL safety integrity level, which is mainly related to reliability of the system or instrumentation functions, and it is called normally SIL and SIF relationship. So before I go, so here there's a 1 minute video. like why SIL is important. It is a Phillips-Borough disaster 1975, where 28 people were killed and 36 got injured. And as a result of this incident, there was like a learning like how these kind of incidents and fires could be prevented, and that's why these standards were basically initiated, IEC 61511 and IEC 61508. And so let us see, video should complete, then I go to next slide. So this incident was in England, Saturday, 1st June 1975, and due to release of hydrocarbon and fire, there were basically 28 people killed, 38 got injured. This is the end result. You can see the whole plant was destroyed and fire was still continuing. Now, there are other incidents as well, like DSM week in 1975 again 28 people were killed, 107 got injured. Then ICMS MESA, Seveso 1976, there was an incident, and where 17,000 people got affected. And also don't forget India Bhopal incident, where the carbide plant got the leakage of like a toxic element, and that caused the disaster in the area. So based on these major incidents, then industry started thinking how such kind of disasters can be avoided or averted or prevented. So as a result, so there are, if you can see from this screen, there are 9 general layer of protection. So before I go to the explanation of these layers, and so someone can say, sir, whether today there is no incident or no accidents happening in the industry, and still accidents are happening, but the numbers of accidents per year have dropped very low. And the reason there is a cheese model, like if every layer is left to be taken care by the next layer, and then every barrier is not being attended, then accident can still happen. That's called cheese model, where the no barrier or no system is playing their role. Under these 9 layer of protection, one is a basic process system, like we say inherent safe design, and then next stage is like a basic process control systems, like BPCS we normally call it, instrumentation and control systems, and that is second layer of protection, where control room is playing their role. Then alarms are there. In the control room, there is also like a control valve fluctuation, or basically of the control valves and maintaining of the pressure, temperature, with the help of throttling of the valves based on the signal which is received from the pressure transmitters, level transmitters, flow transmitters. Then if there is a high level or low level, if there is any action required from the operator, then operator is also able to play their role. Then after like basic BPCS, then alarm and operator intervention, then there is a safety instrument system, SIP. And this SIP system is relevant to SIL. SIP and SIL are related, and SIL classification is done for the SIP. Then there are mechanical protections, like physical protection, like relief valves or PSVs. Then in the tank farm areas, we see dikes, and once, like if there is a leakage of hydrocarbon from the tank, then the fluid can be contained within the boundary of the dikes. Then there's also fire and gas detection system. If there's a leakage, then there could be alarms, or sometimes a fire and gas system, FNG system, can also be linked with the ESD system. Then last, which is coming as an emergency, not least, plant emergency response plan. If something goes out of control, then how to rescue or how to escape. Then community emergency response, which is like civil defense and district management, health authorities, how to communicate with the community so as the disaster, if it happens in any petrochemical plant, that could be managed. So these are, if you see this, there are 9 layers of protections, and still we feel accident can still happen or happening, fires are happening in the facilities, and it is destroying money and sometimes injuring people as well. So it means each layer of protection should be managed properly and as per their performance standard, and then accordingly things can be kept in control and we can avoid disasters. So before I go to the next stage, there are basic definitions like BPCS is a basic process control systems. Then second thing is a cause, like why an incident can happen. There would be a cause, something might have gone wrong, and there's also reason why incident should happen, and if any incident, if you can see or can recall, will not happen all of a sudden, and there is a situation which is once said like time, preserve the causes for a time, for a long time, then incident happen. Then consequence mean if incident is happening, whether there would be minor impact, major impact, or disastrous impact. The consequence could be in terms of environment. A disaster could be, it can impact in terms of life loss or in terms of money loss. The consequence could be on either direction. When we say final element, it is basically part of BPCS system, and like in any BPS system or SIS, there is a basically initiator, then logic solver, and final element. Like ESD valve, or there could be a motor or a pump driver or a turbine should be shutting down. That's called like final element. Now, hazard is like if something is like a potential to cause harm, including ill health and injury, damage to property or environment, production losses, or increased liabilities. Then initiating event, a device failure, system failure, or like initiating event is like how the event would be initiating. And in a SIP site, a transmitter is a initiating cause, but there could be like a error from the operator. There could be some wrong action by the operator as well, which may cause the accident. IEF is how often the IE is expected to occur, like initiating event occur. In LOPA, which is terminology in the SIL, the IEF initiating event frequency is typically expressed in terms of occurrence per year. Then IPL is independent protection layer, like if we have seen 9 protection layers which are playing a role to prevent any failure or disaster. Logic solver normally is a DCS or ESD like a software which is being used by the plant to control plant operations automatically. LOPA is a layer of protection analysis which is used to see the effectiveness of the SIP. PFD is not a probability, sorry, it's not a process flow diagram in SIP terminology or SIL terminology. PFD is probability of failure on demand. Like if any logic solver or initiator need to work, need to perform its function, then how many times it would be successful to do the required function, or how many times it may fail. Similarly, RRF is a risk reduction factor. It is a dimensionless number, and 1 over PFD is normally called risk reduction factor. Safeguard, like any protections or like protections or safeguard mean all the layer of protections which are installed to prevent any incident or deviation from the system is called safeguard, or like lists of the items which can play to prevent the incident. Sensor is normally a transmitter or an instrument which can read the values or number to detect the process condition, whether it's a level a transmitter or a pressure transmitter, flow transmitter, vibration transmitter. These are also called transmitters or sensors. Severity means a measure of the degree of impact of a particular consequence. And if keep the door open so as it not to be like, okay. Next, a safety instrument function. A safety function while a specific integrity level that is necessary to achieve functional safety by putting a process to a safe state or maintaining its safe state. That's called SIF. Basically, SIF is the topic of the day where we determine the SIL classification or SIL subject, where SIF as a defined system like a safety instrument function, or SIS mean the whole ESD system like a level 1, level 2 or level 0, what instrument system would be playing its role in case of any emergency or if any operator given action, that's called SIF, and SIS is the overall system name. Yeah, SIS is there. It is basically main part of our ESD system is SIS, and sub part of a SIS individual loop between initiator to logic solver to final element is called SIS. TMEL, this terminology is used mainly for the SIL classification and SIL assessment process, and it is coming as a targeted mitigated event likelihood, like how much risk reduction is required by the SIF. Target mitigated event likelihood, the maximum allowable frequency for a specified severity of consequence. We will see this as we go to the next definition or next detail of the SIL. Now, what is SIL? I told earlier also. SIL stands for Safety Integrity Level. Safety integrity level is defined as a level of risk reduction provided by safety function or SIF. It is a way to measure the performance of a safety instrumented function SIF. A SIF is a combination of sensor, number one, or sensors. There could be more than one sensor, logic solver, and final elements or final element. There could be one final element, there could be multiple final elements that detect the hazard and bring the process to a safe state. In general, like if you see here, if a hazard is happening, then the SIF is playing its role to bring the system to a safe state. Then if a sensor, logic solver, and final element, these three things make one SIF. Further detail, like when we say SIL of a SIF define the reliability range. Reliability range mean what? When we say SIL is normally defined as a SIL 1, SIL 2, SIL 3, SIL 4. This is based on 61508 and IEC 61511 standards, where RRF mean 1 over PFT. SIL 1 mean risk reduction factor 10, and PFD 10 raised minus 1 to 10 raised to power minus 2. What does this mean? It means that if we check one SIF 10 times, it should fail only one time. It means that system is reliable from 90 to 99%. Similarly, if the same, there could be a 10 population of those SIFs, if we check 10, there should be only one SIF should be failing. But SIL 2 mean failure rate 1 out of 100. SIL 3 mean failure rate 1 out of 1000. SIL 4 mean 10 raised to power minus 4 means if we check one SIF 10,000 times, it should fail only one time. So that RRF is about 10,000 RRF, risk reduction factor, safety point of view. And why we need that kind of reliability? Because if that safety system does not work, there is a huge consequences in terms of loss of life or in loss of basically production or the asset loss. So similarly, for example, if you have a high pressure shutdown with a probability of failure on demand of 0.1, it means RF is 1, like 1 of 0.1 is equal to 100. It meets the requirement of SIL 2. And this is the 100 to 1000 is the basically RF requirement. The required reliability of this SIF is 99 out of 100. It means that it should fail one time if tested 100 times. Or if 100 similar types of valves are tested and only one valve should fail. We can also say that there is a risk reduction factor of at least 100. So this is the normally definition. If I am able to explain properly to you, where the risk reduction factor or the SIL by definition it is being defined. So here in the picture, if we see this, like here we have a PT and logic solver, and there's a one relief valve which is on-off valve normalities, and if due to some reason if a pressure is high and we need to, or low, we need to close the valve, and signal will go, transmitter will send signal to the logic solver or controller will send signal to final element, and by on-off logic it will close or open the, it will normally close the valve, but sometimes valves are also open which are blow down valves. A relief valve is a blow down valve, normally open it, but ESD valves are normally emergency shutdown valve, those are being closed. So next is basically SIF example, another one. Here a combination of basically ESD system, SIF or BPCS is being defined. A basic process control system mean the instruments which are managed by DCS or by operators in the control room, and ESD system is also managed by operators, but that is for the safe shutdown. Here if you see there is a LT1001 and then an LIC101 which is level indication control, and it is throttling the valve LV1001 throttle. Like if level is high, they open the valve, if level is low, it will close or it will throttle in between. However, if level goes more than a certain limit, then signal will go to logic solver and the final ESD valve will be closed due to some reason. So this is the definition, like how the ESD system as well as BPCS system can work hands in hands or side by side. Then there are various level of like instrumentation control systems. Here's the example of a HIP system, which is normally installed in areas where you don't have a relief system, and if a relief system is not available like on the wellheads, then we try to make the ESD system very robust. And how we do that? We can install 3 transmitters, 1, 2, 3, with voting 2 out of 3. If signal is confirmed by 2 transmitters, then the logic solver will close both ESD valves, right? So as incoming fluid can be closed. So as this, because there's no relief, so system has closed the inlet and it will not have an impact on the downward side, or the effect on the downward side could be reduced. So now, if you see this, like a 2 out of 3 transmitters, meaning less doubt if the condition which would be reported by transmitter that could go wrong. Secondly, there are 2 ESD valves. If one of them is not closing, at least one should close. Like it is least expected that if the both ESD valve will not be closing at that particular time. So here, SIF example, like I try to go. Another one, like we have a BPCS with normal operation, CVUM, and there is a SIS at XV1. Now, there is a small test, like what we discussed up to now, and if all of you or any of you would like to write your answer, you can write in the chat box, and our team will also look at who is writing that. And then at the next stage, I will also show that. Then you should be able to compare your answer with the result. For example, is the role of a mitigating type SIF to prevent a hazard, A, or B, reduce the escalation, or answer could be to both. So please check and fill in the chat box what is your answer. It is just checking your memory, like what I told up to now, whether I am able to convey the message to you. Then next, how many subsystems make up a SIF? Like how many subsystems, how many components are there in one SIF? Okay, question number 3. Name basic subsystem of a SIF. Basic subsystem of a SIF. Name. Question number 4. What is the PDF range? It should be PFD range. This is a typing error, I will believe. PDF is not PFD range for a SIL1 function. What is the probability of failure on demand range for SIL1 function? Question number 5. write the risk reduction factor expression. Like write the risk reduction factor expression. So if all of you have written your answers, then now I will go to the next slide where answers are provided. Is the role of a mitigating type SIF to prevent a hazard or reduce escalation? Is both A and B correct? How many subsystems make up a SIF? 3. Initiator, logic solver, and final element. Names are given in question number 3. Now question number 4. SIL1 function, the PFD range is 0.01 to 0.1, 1 out of 10 failure rate. Similarly, write the expression. Risk reduction factor expression is RRF is equal to 1 over PFD. So at next stage, we will also give question answer session at the completion of the next session. And then please write your questions on the, not chat window, on the question answer, I think, screen, right?
Yeah.
Question answer side, right? Yes. Where the participant need to write answer questions?
Question and answer.
Question answer session, right? So write the question answer area, Q&A. Please write your questions in the next session. Then we will be asking participants to read their questions, and then we'll give answer from here. Then please, at that time, you have to give your name, company and country name, so as people may know who is asking that particular question, and we'll answer jointly. Next thing, like we will be doing first as a SIL determination. We need to understand SIL is determined at 2 stages. One is at EPC project stage or engineering stage, and second SIL is determined at operation stage. And in a way, the SIL determination process is same, but objective may change. This is what I'm giving as a preempt. At EPC stage, if it is being done at feed stage, then all stakeholders are on the same page. But if it is being done at EPC stage, then the contractor, the EPC contractor, engineering, procurement, and construction contractor, their intent would be to reduce the SIL level, required SIL level, so as they can buy cheap or less reliable equipment. Because if they have to buy high reliable equipment, their cost would be more. So, in a way, at EPC stage, SIL when being determined, it has to kept in mind you are looking to buy a high reliable equipment or less reliable equipment. So the SIL determination concept at EPC stage sometimes may misguide participants. Similarly, SIL determination at operation stage is normally focusing to determine test interval for the SIPs. And at that stage also, if a company engineers or company maintenance or inspection department, they would be looking to reduce number of SIPs which should be tested every 3 years, every year or on stream. They might be trying to reduce those numbers. So again, the SIL determination may be focused on the lower SIL side, and for doing in both the cases, the consequences are considered on the lower side, and TMEL, the target mitigated event likelihood, is taken on the lower side, and SIL is considered on the lower side. So these two things, when there's a balance, SIL should be determined both at EPC stage and as at operational stage with right intent, right methodology, and compromise should not be made by considering the effect of the consequence on the lower side, and then SIL is also determined on the lower side. That's why there's the best industrial practices we have seen, like under Norwegian standards, and also ADNOC has also determined like minimum SIL 1, and in Norwegian, basically I can refer your standards where they say in case of PSHH, LSHH, minimum SIL should be 1. For LS high or temperature switch high and temperature low, but LSH high knockout drum where liquid carry over to compressor is possible, and it may cause the damage of the compressor and fire. Or there will be gas blow by cases also. If the gas goes to the lower pressure system, like a drainage system, it can also make plant in a horrible condition. So the minimum SIL level 2, but TS high I1 and PSL like a process like a pressure switch low leak detection is 0. No means no SIL required. Similarly, for other areas also where the best industrial practice is saying pressure segregation for valves, pressure valves, SIL level 2, depressurization pressure valve like blow down valves 2, then well isolation single valve, it should be 3, chlorine isolation 2, fire and gas detection 2, electric isolation 2, deluge system 1. So here what this best practice is saying, for these systems or these type of valve, minimum these SIL levels should be followed, irrespective the SIL determined by the participant in the session or by the SIL determination process could be on the lower side. Now, this is the reference what we are referring here is coming from the basically best practice of the Norwegian standard. Here in ADNOC, I have seen they are saying at least at SIL determination, SIL verification level, minimum SIL level 1 should be considered for all the loops. So, no applicable standards. Main SIL, which is basically controlled and assessed, is basically IEC 61511. This is a standard which is safety instrument system for the process industry. Framework, definition, system, hardware and application programming requirements. Similarly, 61508 is basically all the program or the logic solvers, how they should be designed and safely tested. Then there is also ISA standard, is a safety instrument and function SIL, safety integrity level SIL evaluation technique part 1. So there are other parts are also there. So what we are trying to do here, like as a part of this orientation, the participants will try to get familiar with the what are the applicable standards and what is the basic technique. In normal, my view, SIL is not a very difficult subject, but it needs to have some knowledge regarding process engineering, process operations, and then instrumentation side. If you have the basic knowledge on these 3 areas, or you have 3 engineers coming from one from the process, other from the operation, and third from the instrumentation side. If process safety is also there 4 engineers, you people can do a good SIL study, and it's not so difficult subject to handle. So now, when as per the standard, the life cycle basically of a SIF. See, for everything, it starts from the from the birth to the retirement. So here at feed stage or at concept stage, then feed stage, EPC stage, then commissioning stage, then it goes to the operation phase and the overall management and then decommissioning. So the life cycle is same like a project life cycle, and the SIFs are taken care from the beginning to the end, and there's a normal concept. Here, like various phases are there, and we can make these phases more difficult or easier. Both ways are there, but we know that at feed stage, then at EPC stage, commissioning stage, or then EPC got E for engineering, P for procurement, C for commissioning stage, and then operational phase stage as well. It could be made more steps, like there are 11 phases are being referred in the system, and more details are there in the system as well. But in general, we have to take care of the SIFs or instruments at each phase of the project life cycle. So next is why we need a software for SIL studies. I have the answer, like a SIL classification can be done. Classification can be done by Excel spreadsheet also, and then but SIL determination is once done, then SIL verification is also can be done by Excel, by using Excel spreadsheet, and we have both options available. However, when it comes to like we got not hundreds, there are thousands of the SIPs in one particular facility, big facility. Like we have worked on the projects where number of SIPs ranging from, let's say, 100 to 4,000, 5,000 also. For a refinery, there could be 3,000 SIPs, and for a fertilizer plant, around it is both urea, ammonia and urea, utility and offsite, there could be up to 3,000, 3,500 SIPs. So if you wish to arrange all that information in Excel, the spreadsheet become very bulky and very slow in movement. So because of that reason, like it's better if we can use some software. Velosi has a VAIL-PHA SIL module. We are using that for various studies. Those spreadsheets we will show you. There's also available for public use, and we are selling that software also, and we are using that software in our consultancy studies as well. Basically, what my presentation slide is telling, the data for the SIF, whether it's engineering data, operating data, model, then SIL techniques, whether it's a LOPA, risk graph or risk matrix, then SIL determination, then for spurious strip assessment, and then SRS as well, like a safety required specification. So all these information, if we try to see in normal Excel spreadsheet, that become bulky, it's better to use the software. Like we're showing that it's not a promotion, but we're saying you can use either VAIL SIL software or maybe some other software as well, which are available in the market. Here, like we try to do like SIL start with the HAZO process or what if process, and then like and in our software which is available, both HAZO, what if, FMECA, and then RCA and safety integrity level. But we are focusing only on the SIL here, and this SIL assessment is done in accordance with the IEC 61508 and the IEC 61511 standards. So here, like the workshop, if we're conducting, which people would be participating in that particular workshop, the detail can be added. Then the company details for which the SIL study is being done. Then sessions, like each session there could be conducting various sessions at various times. Then SIF information, which is on the upper side of the function, like location of the SIF, PNID, description, then its consequences, effects. So this is a screen. What we are trying to show is the risk graph, and similar aspects are also applicable on the LOPA or risk matrix side as well. Then SIF data, if you can see it, for example, initiation, then logic solver and their details, final element and their detail, then SIF narrative. If we try to add this, so this all information, if we try to put in Excel, it will become a little difficult to handle, even though I will show you how it can be done in Excel also. But if you're doing in the software, then it's easy to manage. Here, SIL determination technique, there are three techniques which are normally we follow. One is risk matrix, which is qualitative. Risk graph is also qualitative, but I can say between qualitative to semi-qualitative, in between. And then layer of protection analysis, LOPA, which is normally is more respected in the industry, that's called semi-quantitative technique. And we will be covering this. Now here, when we go to like risk matrix aspect, so in that there are three elements, three consequence areas are covered by the SIL. One is safety, environment, commercial. So then user can specify severity level and probability system. We will calculate the risk level and SIL level according to the matrix. We can show you at the software demonstration stage like how we do it, and it's easy to follow it. Then SIL determination using risk graph, which is one of three. There are basically three main factors which are important under risk graph methodology, like a demand rate, which is W. Demand rate means how many times in a year the SIF is required to act in case of any emergency, like how many times that emergency level or emergency scenario will arise. Consequence C, like if SIF is not protecting, if SIF would not be able to protect or act, then what could be the consequence? Occupancy, like if we're looking at people, how many people are there in that particular area? Then next step is probability of avoiding the hazard. There are relatively quick methods. They tend to be conservative. They can be qualitative or semi-quantitative, and they work better if semi-quantitative. So this is like a normal SIL determination by risk graph. Here the process begin by defining the equipment under control, which is called EUC, equipment under consideration, basically I would say, and the environment in which it is operating in the following sequence. Number one, identify the boundaries of equipment under control, boundary from where to where. Identify the hazard associated with the equipment under consideration. For each hazard, assess its likelihood and consequence of occurrence without any protective system. Knowing the frequency and consequence of all hazards determine the current risk level. Determine whether the current risk level are acceptable. If risk levels are not acceptable, then consider the risk reduction to be achieved by external risk reduction factor. Then if an electronic or electronic programmable system based on SRS is required, safety required specification, then utilize an approach such as the risk graph to determine the requirement for a SIL level for proposed system. If a SIL level is required, determine if the design of the proposed safety system meets the numerical requirement for probability of failure on demand for SIL level specified. Ensure compliance with the remaining requirement of the standard for particular SIL level chosen in terms of documentation requirement and software architecture and testing requirements. On risk graph methodology, there are basically three type of risk is considered. One is a safety related risk, other is environmental related risk, and third is a financial or commercial related risk. There are 12 slides, which is we're going like how it is being done and how this like a start, then function P, W, and how it works. Like if we say risk graph, there should be basically, it does not go, we go by the graph, but there should be actual SIF. And if we try to do that, then it could be easy. Let me see how it can be explained further better. Safety, C is like extent of damage, consequence, slight injury, severe injury, death of several personnel, catastrophe. F is the frequency and exposure time of the people, seldom to relatively frequent to continuous. Hazard avoidance, mitigation, fire and gas detection system, possible under certain conditions, hardly possible. Then occurrence, probability, very low, low, and relatively high. If we take one SIF, like in a particular pressure vessel, let's say if SIF does not work, so if there would be failure or rupture and there could be a fire, then we have to see how many people would be available, have an impact on that area. So these are CA, CB, CC, CD. So if we consider like the death of several persons, then CC, it will go here. Then we say frequency of exposure time, how much time people would be there. Seldom to relatively, if we say frequent conditions, then we have to select the B, FB. And FB, then we have to say P and PB. If there's any avoidance possible by fire and gas ejection system, let's say it's possible, then we got what the rate of how many times this SIF would require to act per year. Let's say if very low, or relatively high, if we say low, W2, then SIL level 2 is required for that particular SIF. So it's so easy to determine the SIF if we know the condition. But we should understand what process we are doing, and PID is in our front, overall a layout area, how the plant is being operated, and then how the operators are controlling the plant operations. So if we know all these answers, so in a very simple, like we picked CC, then we picked FB, then we picked PB or PA, then whether W1, W2 or W3, and SIL will be picked by the system itself. So it's so easy if we know the process, how it's working. So here, if you see this, further more details are being provided here, like CA is a minor injury. I did the same example here. CB is a range, CC this range, CD this range, like a number of people or defects. Then here FA is a rare exposure in the basically in the hazard zone, occupancy less than time point of view, then are frequent. Then if we see a probable exposure, this detail is also provided, comments are there, how to use this basically. So this methodology is available in IEC standard. Since my time is low, in general, we give SIL training in 5 days. So I am doing this webinar in 2 hours. So I'm cutting a few corners, but I'm trying to give this message. SIL assessment is not a difficult subject. It is relatively simple, but we need relevant knowledge, or team with relevant knowledge. Then PA/PB is the same aspect which I explained earlier, and then like probability of avoidance. Then W1, W2 is a like occurrence required by requirement of that particular shift in 1 year time or more than a year time. Accordingly, we have to pick W1, W2, W3, either one, and then we can get the SIL of the target shift. So this one like is the same graph from the software. So we can pick from the risk graph safety one by one item, and we can get the SIL determination. As we go risk graph software, I will show you after the completion of this session how the software can help, and it could be managed by Excel as well. The same thing for environment. In the environment, one thing is basically removed. We'll see that. That is basically, if you see, F is exposure. Like how many operators would be in that particular area? Like if I go, like best thing is to explain everything to this slide, where I have a C, I have a F, I have a P, and W. There are 4 basically variables. If we try to select for each SIL would be determined right or wrong, right? So this is the risk graph method. In environment side, seldom to relatively or frequent to continuous. Basically, environment-wise, if fluid would be released in the environment, it would have its own impact. So in the SIL related to environment, F factor is not applicable. Similarly, for a commercial SIL plant would be there, it can be affected. For both safety, economical, commercial or environment, F factor is not the risk graph, where safety aspect, where people and PLL, potential loss of life is expected, where F is important role. So here same like what is the impact, like a minor damage to environment, severe damage to environment, or unacceptable level, for example, oil release in the sea, which may cause the effect on all the shores, is a very consequence-wise more important than the onshore side. So those aspects, the scale, what your plant would like to follow. So these scales are provided, and we need to follow these scales, whatever is applicable on our particular ship and the plant, where you would be doing this assessment. Same risk graph, like here, PA, PB, F factor is not there, all 3 factors are same. This is the last one, the software, when we can click that, and it goes basically by our aspects. Right. So this is like we are just showing that it can be done by Excel, but in the software side, we can pick it, and this exercise would be done at the next stage of this session. Then is a commercial aspect. Same commercial mean how much damage it will cause to equipment, and how much money would be required to be spent by the plant owners in case something goes wrong. So again, I will remind why we are doing SIL. We are doing SIL to check the safety integrity level of that particular ship, which would be able to protect or shut down the plant in case of any emergency. And we are also keeping that in mind. If this ship would not be available, there could be accident, there could be disasters. That's earlier example I showed, like there was Bhopal incident, there are other incidents where number of people were killed. So even Piper Alpha also is one of those in North Sea. So how we can determine this SIL is important, this SIF is important, and then how we should do testing, proof testing of these SIFs, and we should not take risk for the investor. So this commercial shows if an investor will not be allowing, or the plant owners or senior management would not be giving time to test the functionality of the SIFs, because shutdown is not being given, or time is not being given, or technicians are not being given to test the SIFs, or SIFs are not installed at all. That could be a scenario. So they can understand how much commercial impact would be there for them. Like here, consequence-wise, total loss between 50K to 500K, or loss more than 500K to 5 million, total loss more than 5 million, or total loss more than 50 million. It could be each company got its own risk matrix and scale, and that scale can be followed. Then possibility of avoidance, the number of times per year the SIF is required. If we try to answer these three variables, we can get the SIF. So it means if we understand the phenomena of risk graph, it is easy to determine the SIL of any particular loop. This is the end, like a software, like how we do in our software. So we got the safety, environment, and commercial graph, and the field recurrence sequence analysis also there, right? Now, before like we go to like SIL by like a risk graph methodology, let's try example using VAIL-PHA. So if I try to example, but so that will be done, I think, later stage. So here is like risk graph. This is Velosi software. If I go to risk graph, so if we try to see, first the safety, one loop is there, and if something is already picked, but we can change it. If I go to edit, see here, CA, CB, CC, CT, right? If we track anyone, so currently if you can see, this is a SIL level 1, and here we have picked CC. If I pick it CD, right, SIL has changed, right? If I pick it as a first one thing CA, then no SIL required. Like everything is determined by the consequence determination. If I make like a CB, it is a still no SIL required. But if it's important, then exposure time is required also. If we say more often, possibility of avoidance, SIL 1. But if I change it, let's say almost impossible, then it go to SIL 2. So this is a short like exposure on the safety side, and then accordingly from this table, SIL is being given by the software. It's not so difficult, but question would be like how to pick CA, CB, or CD. The knowledge is required from the plant. Frequency of the people, like a rare of how often people would be around there. It's a manned or unmanned activity. So then similarly, possibility like of avoidance, almost no there. Then there is also like once more than 10 years, once in 1 to 10 years, once less than 1 year, 3 possibilities are there. If we select any one of those, it will have its own impact. If I say once in less than 1 year, then SIL 3. Same thing if I change less than SIL 1. So this is way we can do it. Similarly, there is environmental, there is a commercial, and there is also failure frequencies, like a failure consequences analysis. This is the data which comes normally from the as-of. So if we see this graph again as a SIL methodology, a software point of view, it's not so difficult. Even Excel point of view is not so difficult because it's got only 4 questions to be answered. C should be selected, F should be selected, P should be selected and W should be selected, and you can get the SIL. But the data, where the SIF is located, how it is operating, is that we should understand. Right, sir? Similarly, there is a risk matrix which I covered earlier. It is even more simple, like whether it's a safety, like severity. Ali, there's some problem. I cannot see the text. Okay, so maybe some with my configuration and this laptop connection. So if we have the values same way, risk matrix is going to be frequency, so we can get risk level and the SIL level as well. So there is some shade is there, right? Okay, no, it's okay. We don't do that, but it's very easy. Like in the severity class and the consequence class, and then severity class, then the probability class, we can get the risk and the SIL level, and this is the simplest risk matrix formula. So next is the, like if I say this is a risk graph, then we got risk graph, risk matrix, risk graph. What we have a personal, summary, session, risk matrix, risk graph. Right now, next would be LOPA. Before we go to LOPA, can we take certain questions now? Because this is a simple thing what we have done. Okay, Adley, if there are some questions, you can ask people to speak, and then we go to next stage. So make it a little interactive.
Hello, Mr. 𝐿𝐤𝐢𝐿𝐤𝐢𝐿.
Can you raise your hand and unmute yourself? Mr. 𝐿𝐤𝐢𝐿𝐤𝐢𝐿, please.
I cannot see the questions. Let him, if he can read the question. Whether Mr. 𝐿𝐤𝐢𝐿𝐤𝐢𝐿 would be reading his question. Okay.
Yeah, good afternoon.
Mr. 𝐿𝐤𝐢𝐿𝐤𝐢𝐿, can you tell what your name and which country or company you are speaking?
Yeah, my name is 𝐤𝐤𝐢𝐿𝐤𝐢𝐿. I'm based in UAE, working with ADNOC.
Welcome, sir.
Okay, so I put two questions for any comments. The first one was probably I don't recall the first, but second one I know that you mentioned three different methods for the assessment of SIL, the risk graph, and this matrix and LOPA. So yeah, so out of all these three techniques, so which one is more preferred, and if we have any for the same scenario, can we compare all these three techniques which give us the most kind of SIL level which is more close to the requirement, or realistic one, or which is more conservative?
Thanks for your question. See, three techniques. One is risk graph, risk matrix, risk graph, and LOPA. And result of all three can be compared. So what we are used to follow two, not risk matrix, risk graph and LOPA. These two techniques are normally people do and compare. Risk graph is more conservative, results is more conservative. Like SIL level is generally high in the risk graph. But when we go in LOPA, we can make more realistic analysis by considering all the IPLs, and the result is more accurate as compared to risk graph. So that is the sequence. First, risk graph is easy to do. LOPA, SIL assessment, that is a little bit more complicated. But if you will see that that's also not so difficult, which people cannot do. And then we can compare the result of both techniques and use the technique, whatever we need to prefer. This is the first answer. Your question regarding SIF can be added in SIS. It is not like we add SIF in the SIS. Like any shutdown system, if you see in the plant 0, 1, level 2, level 1, or level 0, like level 0 could be full facility shutdown, 1 could be a particular train, or 2 could be a particular section of the plant. So all the SIFs which are coming in those particular shutdown levels, the shutdown level is called a SIS, and all the SIFs coming under that particular shutdown level would be called SIFs. If it clarifies the answer. And
yeah, thank you.
Yeah. Thank you, sir. Any other question next?
Mr. Anas Ahmad, can you unmute yourself and read
Mr.
your question?
I cannot see the question.
Wait, sir.
Training attend call.
Mr. Anas Ahmed, yes.
Yes, my name is Anas bin Ahmed, and I am currently doing job in Chevron, Kazakhstan, as a PLC engineer. Actually, my question was in very early stage. I just wanted to ask the difference between a SIF and a SIS. Like, what
No,
is a
it's okay. We appreciate at least this question answer session telling us now, like from which areas people are participating in this session. We are very glad to see people joining from Kazakhstan, from Adenok and other areas as well. So yes, when we ask such question, it helps other people, maybe students and maybe young engineers, to like what is the difference between SIF and SIS. Basically, SIF is one loop, one transmitter or group of transmitter with one logic solver and final element is called one SIF. Keep that question there. Yeah. So the question is being answered there here. Yes. So that's called one SIF. And ESD level, any like in plant, various ESD levels are there, like level 0, level 1, level 2. And normally it is said full plant shutdown, it means all SIFs would be part of it. Then area shutdown, it would be only one part of ESD system. Train shutdown, one other part of the SIS system. So SIS is a overall system, ESD system, what we call it, and SIFs are the part of the SIS. Okay.
Thank you. Thank you.
Next question, please.
Next question from Mr. Said Iqbal. Please unmute yourself, sir. Mr.
Yes,
Said Iqbal.
question. Is equal available? Okay, so we can read the answer is from Parko, Pakistan, and this question is how to calculate reliability. Basically, in the SIL, PFD is indirectly reliability. PFD means basically probability of failure on demand. And if we are saying SIL 1, it means the reliability of the system is 1 out of 10. 1 out of 10 failure rate. Like if we will testing that system, it would be almost 90% reliable. So that is the message. Like SIL is helping us to calculate the reliability of the system. Next question, please.
Next question from Mr. Muhammad Rahman.
Yes, Mr. Rahman, any question? You can read your like a name and company and question. Mr. Muhammad Rahman, because we don't know from where you are basically.
Mr. Muhammad Rahman, can you please speak?
Okay, anyway, I can read the question. Like who determines the level of SIL? We determine the level of SIL. All the participants who are participating in this webinar, we can do SIL determination of the loops in our company. Normally, as I said earlier, if we have 4 type of knowledge in one person or 4 different people, like process engineer, operation engineer, process means process design, then process operation, process safety, and instrumentation engineer. If we 4 people are there, we know what our shifts are installed on the facility, then what are the details and which area they are installed, and then we can do SIL determination. Next question I can read here, we can see in the beginning, there like anonymous attendee asking question, can you share some practical case studies of successful application of that? I will be sharing my case study at the end of the seminar also, as last part of the seminar or webinar. See, we do have a SIL certification program under Velosi, and that can be followed, and then the person can be a SIL expert, SIL professional who can do SIL classification. And without that certification program, you can also do the SIL classification. It is not that difficult exercise as such. However, it is a multi-dimensional study, and a multi-dimensional knowledge is required. That's why it's better to have certain training and certain certification practice. Next question, please. Next question from Mr. Muhammad Rahman. Please unmute yourself.
Hello, sir.
Any other question, or we can go to next?
There's a question from Mr. Bilal Ahmed. Sir, please read your question.
Yes, good afternoon, Mr. Rao. Thank you very much. It's really lovely to see you first time as training us. Many times we attended the seminars with Velosi. I'm talking to you guys from KSA. I'm working with Parsons. My question is, you have mentioned actually two things. One was about SIL at EPC stage, and second was at the operation stage. Maybe I was unable to elaborate in my written statement, but my core question is that if the EPC times or EPC stage SIL is not considered as sufficient and suitable for the operation stage, so will all the design be like reframed and we'll be starting from zero?
No, it's like if you participate in any HAZOP session and SIL session, right? I share a practical example. Like I will not give the name of the company. We have seen HAZOP deviations and HAZOP consequence severity rating assigned by the HAZOP team. When we went to the SIL stage, and the SIL was coming higher, 3, 2, 4 is not acceptable, that goes for recommendation, even 3 and 2. Then the SIL team will say, oh, the severity assigned by the HAZOP team is high. We don't expect there would be so many fatalities or a severe effect on the asset. Let's reduce it. Then they will reduce the severity in the HAZOP side, and SIL will go on the lower side. Consequence meaning is like if you need any additional layer to reduce the risk, that layer will not be provided. Secondly, if you need high reliable system to have a better performance of that particular recipe in future in operation phase, that could be compromised. That normally happen in the project stage where somebody is trying to convince all participants, mainly from the EPC side, the consequence cannot be so high in this particular area of the plant. Same is the case when we go in operation phase. Basically, EPC stage are like a layer of protections or instrument systems are already installed. Now, our part is just to determine re-verification of the SIL and determination of the next testing interval. Whether SIF should be tested, let's say, every 6 months, 1 year, 3 years, 6-year basis, and why. And that goes by the SIL class, SIL 1, SIL 2, SIL 3, and failure rate. And as per the applicable configuration, we can calculate testing interval. We'll cover that next part. So if SIL is lower, 1 or even 0, then if 0, no testing required. If 1, testing interval could be longer. And then failure rate, whether there would be a plant failure rate or it could be industry average data. So if industry average data is taken, then it is industry average. So in those scenarios, the drawback of SIL is if the consequence or severity is considered on the lower side or even higher side, it can vary. The result reliability may vary. So it has to be with serious determination, serious effort, so as we don't compromise on the applicable risk. I know it's a long debate, but this much I can explain at this
Oh, thank you. Thank you. That answers it. Thank you, Rafsar.
Next question, sir, from Mr. Muhammad Arif. Please unmute yourself.
My name is Muhammad Arif and I am from Pakistan Oilfield Limited. Sir, my question is, you hearing me?
Yes, please.
Sir, my question is, if a company, if I talk about my company, our companies in Pakistan here are not spending too much money on the safety. So how can we convince them to spend these on these expenditures like SIL or LOPA, or because to enhance the layer of protection, we have to spend money on it. So how can we convince this culture?
Mr. Ariful Haq, I am also from Pakistan, and we do have operations in Pakistan. Velosi is quite active there. We can see that companies like, for example, Fatma Fertilizer, Arco, and even PPL, companies are basically working on the new technologies which can help to enhance safety and integrity of the facility, because it's a future saving. Secondly, SIL determination. See, if ESD system is part and parcel of every facility, it is already installed, because in absence of any safety shutdown system, you will not be able to shut down the facilities in case of any abnormal situation. So it means whether you're doing the shutdown
Right.
by BPCS or normal control, or by ESD system in parallel to BPCS, it is there. The second part is SIL determination. SIL determination is not very costly activity. Like how many shifts are there, then accordingly, if you try to apply this LOPA yourself, not LOPA, risk graph by yourself, and your team will be able to determine the rough SIL for your facilities. And then accordingly, what should be the testing interval and so on. So first of all, it is doable by your own resources as well. Secondly, it's HAZOP and SIL, two basic needs for the plant safety. And in my view, whether it's MOL or the POL or the OGDCL, PPL, and MPCL, all of your companies are in this debate, and I consider, like, we have been working very closely with MPCL. They are also following the modern techniques, and like
Right.
being fair with the organization, this standard was issued in 2008, like IEC 61508 is issued in just 15 years ago. Before that, system are being built, being used, but it is a new learning and it should be followed. Thank you, sir. Next question, please.
Next question from Mr. Muradjan. Please unmute yourself.
Assalamu alaikum. I am engineer, a mechanical engineer from Pakistan, Balochistan. Currently, I have been working with Virtual University of Pakistan. My question is that what is the difference between SIL and risk management?
See, risk management, SIL is part of risk management program. See, there are risks applicable on various aspects on the plant operation, right? So SIL is controlling the risk of the plant, which might be triggered due to any abnormal situation at the plant, and then you need to shut down the plant safely. And to shut down your facilities, you have instrumented control system, BPCS, which is control room, and there are also ESD system in the same control room. By pressing one button, you can shut down your all facilities. And to what should be the testing interval? What should be the reliability level of those instruments? SIL help you to determine the required reliability level or versus actual reliability of those instrument systems, which is called SIP, and that is the objective of SIL determination. So simply, your answer is SIL is part of risk management program.
Thank you.
Thank you, sir. Next question, please. Okay, sir. Next, Sufyan is there. I worked as a lead laboratory engineer. Do you have any certification related to the field of testing? Because that's not relevant to this basically exercise, because we're talking only on the SIL. Next question is also there. ESD will open and BDV will close. No, ESD will close and BDV will open normal any ESD shutdown system. Okay, sir. So now I go back to my presentation, and we will have one more, like one or two more, maybe one more question answer session at the end of the session. Or so please keep your question writing, and we'll like it's nice to see how the people are participating in the session, and then from various parts of the world. Okay, sir. So the VAIL-PHA 1 exercise we have done, right? And next would be LOPA exercise. So what documents normally we need for SIL determination if we try to see? Okay. The one is a piping instrumentation diagram, P&ID, cause and effect diagram, interlock information, then approved HAZOP worksheet if HAZOP is done. If HAZOP is not done, we can still do SIL classification by considering deviation by ourselves. Then PFDs also will help to see the simplified version of the process. Here, like one of the ESD system, which is marked, is a SIF. and which is marked on the PNID. Then we have to see this loop in the cause and effect chart, like how that particular loop will be, like there's one transmitter which will be activating the activity, and then it will stop the reactor inlet of the pump, right? So then the second thing is cause and effect chart. Then this is the HAZOP sheet. If it's available like a human error, then if you see this, it says human error, inadvertent closing of a manual valve on a seal flushing line, then polymer fouling of the pump mechanical seal leading to failure of the seal, further leading to pump stop, plant shutdown, and LOPC. And this is the severity 4 is given, which is the risk matrix position. And then the safeguards, current safeguards, really provide with low flow alarm. Then affected pump around loop can be taken out of service and depressurized after isolation. Plant can be restarted with standby loop. So this is the basically one loop which is considered in this SIL assessment. Now here, when we add all those values, right? So SIL classification can be assigned by the software in the LOPA technique. So we'll go LOPA next. Like here, LOPA stands for layer of protection analysis. LOPA is the process to re-evaluate. I will do an Excel side as well. This will be more explanatory for you, with explicit risk tolerance for the specific consequences. LOPA can be used at any point of the life cycle of the project or process, but most effective when implemented during the front-end engineering, when process flow diagrams are complete and PNIDs are being developed. For existing processes, LOPA should be used during or after the HAZOP review or validation. LOPA determines the safety integrity level that should be assigned to a safety instrumented function, SIF, through calculating the risk reduction provided by IPLs against a hazardous scenario, as definition point of view. So here, like let's be going for the determination point of view, like identification of the SIF. LOPA start by selecting the SIF from the PNID and cause and effect chart. LOPA team should understand the SIF function, description point of view, and the consequence of the hazard it prevents. This is the like a definition. So we have the ESD loop, for example, SIF description, high pressure in the reactor. Initiator is the PH001. Initiator ESD to prevent overpressurization of the reactor R001. Logic solver is ESD based on logic execute sequence of the actions. Then we're saying the SIF narrative is what? High pressure in the reactor R001 detected by pressure transmitter high PH001. Initiate SIS safety critical action via ESD logic solver. Then standard is this client guideline with SIL methodology. Some client name has been changed, so for the secrecy. Then HAZOP study done, report, and this if a graph sheet is this one, LOPA is to be performed. The basic information is provided. Then below is the LOPA understand the HAZOP, which I showed you earlier. Then TMEL values. TMEL values comes from the target mitigated event likelihood, which is very important, which comes from the basically safety is a 4, 1, 3, 1, and highest a 4. And this value is taken to, if I show you, if safe TML 3, it means 10 raised to power minus 5. Environment 3 means 10 raised to power minus 5 again. And this comes from the risk matrix of the company. And see, this is the little time-taking activity to understand. And that's a limitation for me. If we could be doing one exercise together, in 30 minutes time, we can understand, but my time limitation, I can show you in Excel, but explaining you, it's not so difficult, but this is the only thing to understand what the severity and TML relationship, and SIL mainly rotate around it. If it is low, SIL would be low. If it's high, SIL would be high. Then there are layer of protections. How many layer of protections are there, and how those layer of protections should be used. And then we get the SIL. One is the, if you can see here, SIL safety integrity level, EIL is environmental integrity level, and C is the commercial integrity level. Then determination of the initiating event, basically that's this factor, like loss of reaction in the reactor, this, and likelihood, initial likelihood 0.1. Then BP says that basically IPL rule coming in at 0.1. If both multipliers are giving you IEL is division of the TMEL, and we get the basically RF, and RF is given us basically the SIL level. Once TML is determined, the initiating event cause in the HAZO worksheet that could lead to that hazard are to be identified. Then the frequency, probability of occurrence, so those events are to be determined. Initiating event can be due to equipment failure, human error. This explanation I'm giving, but if you do exercise, then it would be easy to understand. I will do then Excel side. Okay, identification of IPL, like what are the protective layers, and these protective layers would have their own PFD, like probability of failure on demand. For example, if BPCS network interlock, it is a 0.1. If it is a check valve, dual dissimilar check valves in the clean service, 0.1. Similarly, PSV, the PFD or risk reduction factor is 0.01 for the clean service and 0.1 for the dirty service. The IPL, how we use them. Then SIL determination for process using LOPA. Step Y, once initiating events and IPLs for an event scenario have been identified, the IEL, intermediate event likelihood, can be calculated by using the following formula. IEL is all the layer of protections and their PFDs are multiplied, right, along with the initiating event for one basically scenario, one cause. For each cause, we need to do this, and we add up all those causes, and then SIL is determined. We'll show you next. So here, step 5, we have calculated IEL by multiplying all the protective layers with their PFDs. Step 6, the required PFD for a SIF being assessed can be calculated from the residual risk frequency using the following. Like PFD, which is probability of failure on demand, X is a TMEL divided by total mitigated event frequency. And once we get it, step 7, where 1 over PFD, like following the calculation of the PFD, the required risk reduction factor, RF, for the SIF can then be calculated using the following 1 over PFD, and that will give you the risk reduction factor, or even from the PFD also, we can calculate the required SIL. So if you see this, LOPA is little complicated, but you do 1 or 2 exercises, it's very easy to follow. So don't get worried, and if you will do yourself by using either software or even Excel spreadsheet, I will also show you the Excel spreadsheet. See, following the calculation of RRF, for each risk category, the risk category associated with the highest RRF value can then be considered to determine the risk. Then the software, like what we are showing you, let's try an example to understand the LOPA methodology using VAIL-PHA. So here, testing interval is next. Like we can leave it and go back to the determination. See, software side, if I got LOPA here, it's already there. For example, edit. So here, initial likelihood by putting the layer of protection and the detail we can add, alarm. So, and then basically additional protection, PSV, and this, then we get the SIL. By changing these, we can get the other results. Now, since in the software, it is like I would like, because this cannot be explained so fast. So Excel is very easy. And I'm trying to show you that Excel spreadsheet now. Can you see my screen? Excel. Okay. So here, first of all, we try to prepare SIF list for all the SIFs. This is for ammonia area. Then under that, what we have it, site, unit area, cause effect interlock, logic diagram number, pin ID number, SIF tag number, case number, SIF description. Then this is a draft SIL, like what we have determined. We'll show you. Then here, previous SIL, target SIL, and remarks. But we see some remark has a reference available, not available. Next, This is the, like we see one sheet. This is the basically Excel spreadsheet, which is easy to follow as compared to even software, because here we have the normal SIL and and SIF detail, P&ID number, cause and effect chart, equipment tag number, SIF tag number, then SIF description, hazard scenario, which is coming from the HAZO. Then this is the TMEL, which I explained to you in the software. And then this is the interpretive published by like a HAZO reference. And then here are this is the initiating event, IEL, and then PFDs on the various layer of protection. When they're multiplied, we get the IEF here into PFD. Then other causes, all of them are added up, and then we get this is the formula PFD is equal to TMEL over FX. So if we try to do SIL by Excel spreadsheet, LOPA, this is to me easy, because here we can, like a P&ID, I can make a hyperlink and my loop is there. Similarly, if I go to like a cause and effect chart, by clicking the button, I can see it is there. I can check. Similarly, for HAZO reference, I can make hyperlinks and I can see my loop there. So by having Excel spreadsheet in LOPA, it's easy to do. And software-wise, information would be at later stage, we transfer this information to software as well. LOPA, we prefer to do in Excel, and then we import into the software system, because next stages, which can like a SIL verification, testing interval, SRS, all those things are easy to manage in software. Whereas when it comes to the links point of view, then that is easy to manage in the Excel spreadsheet, and people can understand like in the one spreadsheet. So we are using both options are available for the presentation point of view. So presentation, can you go back to the mode? Okay. So methodology I showed you both, but the practice which can be done in this time, we have to leave it there. But next time, or if you have to do more exercise, some other model can be used. Okay. Next slide. Next. Okay. Testing interval. Now we are going to the SIL verification. Like, what is the purpose of the SIL? Like now, if we are determining the SIL, what is the purpose? There are two purposes, as I said earlier. At EPC stage, we have to buy equipment. So we need to determine the SIL so as we can buy equipment with that particular SIL classification or SIL reliability. Secondly, in the operation phase, our main objective is to calculate the testing interval. So it's considered to be a major parameter in the SIL verification phase. SIF testing interval signify the interval at which the periodic proof tests are conducted. It indicates how strong this requirement is, as during the SIL verification, the proof test interval may be adjusted to accomplish the target SIL. Here, PFDs are there, and this is a formula for the SIL termination. And the below is a spurious test, like a spurious rate, which could be accepted as a, like a spurious strip. How many spurious strip could be accepted for the nature of loop. So here, for simple loop, which is 1 versus 1 vote, 1 out of 1 vote, half lambda du ti. Ti is the testing interval. Du is undetected failure rate. So the failure rate of the loop or a particular item, like initiator, logic solver, or final element. So if this is the SIL data, failure rate and testing interval can be calculated. For the second configuration with 1 out of 2 transmitters, if 2 transmitters, if the one transmitter is giving you a signal, then this formula. If 3 transmitters are used to give the signal, if 1 out of 3, then this formula, 2 out of 3, this formula, 2 out of 4. If the 4 transmitters are installed, this formula, right? So this way we can use calculate testing interval. It's not difficult to follow. It can be used by Excel or by software as well. Okay. SIL verification is also like whatever the testing interval, if we add in, and failure rate, whether actual versus, we can also use from the EXIDA or URIDA data, where is average industry failure rate is there. If that failure rate is added, and with the testing interval, we can calculate the PFD. So then we can compare the PFD of the basically actual versus the desired. Actual mean what we calculated, and earlier at the design stage, SIL determination stage, then we can see whether both results are matching or not matching with the testing interval. This is the PFD, and this PFD can be compared with the earlier SIL. This SIL 2, this is the testing interval. So this is the part of SIL verification for initiator, logic solver, and final element. These calculations are made for each item of the SIP, not SIP. So SIL verification is carried out to calculate the actual SIL level or PFD of the SIP loop to know if the risk reduction required is achieved depending upon following factors: architecture voting, testing interval, and reliability data. Right here. SIL verification is carried out by using simplified equation method, and there could be some complicated formulas are also there that can be used as well. VAIL-PHA software is designed and developed as per ISA TR 8400.02 to carry SIL verification. These are the formulas. STR is a spurious testing for the spurious strips. Then where dangerous failure rate, TI is testing interval, PF is the probability of failure on demand. Whereas lambda S is a safe failure rate, MTTR is the mean time to repair, STR is spurious strip rate. Spurious strip rate. So this is the equation which I showed in the software. Architecture voting to be taken from P and IDs and cause and effect chart. It's like how many transmitters are there is actual. The reliability data can be taken from Exida or RIDA or the plant itself also. Testing intervals are adjusted to make actual SIL level equal to or greater than required target SIL levels. Then STR, SRS. STR is a spurious strip rate or safety required specification. The spurious strip rate is also calculated for all the components of SIP, initiator, logic solver, and final element. Spurious stripping in the unwanted tripping of the system caused by any of its elements when no demand occurs. Spurious mean the situation like a fire and gas detection system. Sometimes we receive the alarm, but there is no incident being observed or reported from the system. Actual situation is not there, but trip is occurring. That's we call it spurious trip. So by calculating this, like for example here, safe failure rate this, spurious failure rate this, and spurious failure rate, then we see that whether the spurious failure rate is acceptable or not acceptable. So here SRS, like this is the data like where the software put an information which is more useful. Then here like SIP cross reference, description, target SIL, then SIP initiating devices, initiating voting, functional description, corresponds ESG number which is called SIS, then final elements, hazard, consequences, triggering and tripping, required SIP action, SIP set point, normal operation value, pre-alarm availability, target spurious rate, then proof test interval, demand rate, mode of operation, manual shutdown, trip, bypass, overdues. All this information is required to be filled. That's why this system software is helpful when dealing with the thousands of SIPs. So the SRS phase in the VAIL-PHA SIL module provide a template for collecting the safety requirements such as overall response time, trip, reset target, etc. For a safety instrument function, its primary focus is on the collection of information. It is used to optimize the detailed design, requirement communication, and to enhance the process requirement collection. MTBF, MTTR, these are the basically failure rates. Like if a failure is occurring, what is the mean time between failures, or MTTR, mean time to repair. Mean time to repair refer to the amount of time required to repair a system and restore it in full functionality. The MTTR clock starts ticking when the repair starts and it goes on until operation are restored. This includes repair time, testing period, and return to the normal operating condition. To calculate MTTR, you have to divide the total maintenance time by the total number of maintenance actions on given period, right? Now, other things like what technology what we're using, testing interval, SIL verification, then spurious strip, SRS, MTBF, MTTR, these all are the SIL verification functions. Meaning what? Like to ensure that our SIFs are working as they should be working. They are able. We are in control for the integrity management system of these SIFs. It should not be the case. It should not be the case if SIFs are installed and they are not being tested. When there is emergency around the plant, the system is non-operational. This is very, very important, right? The MTBF is the mean time between the failures is the predicted elapsed time between inherent failure of a mechanical or electronic system during normal system operation. MTBF measures the predicted time that passes between one previous failure of a mechanical electronic system to the next failure during normal operation. In simple terms, MTBF helps you to predict how long an asset can run before the next unplanned breakdown can occur. So our system can calculate the total number of testing, number of faults, and the actual PFD, and then it can correlate to the MTBF and MTTR calculations. Reports, the various reports can be generated by the system, whether risk matrix report, risk graph report, LOPA report, comparison summary report, testing interval report, SIL verification report, SIL verification summary report, STR report, SRS reports. Now, before I go to case study, if I show the system again, see here, when we see the software system, why software is required? If you see here, the number of SIFs, there are many. Plant 3, unit, and each unit there are SIFs, or it was SIF types, so many, and each SIF type you can see high level, so many SIFs are there, and each level, because these are in thousands, then area is also changing. So if all these things we try to see and this data, then it becomes troublesome, like drawings, attachment, bulk data upload is possible, comparison summary. And here, if let's say one by one, personal, summary, sessions, risk matrix approach, risk graph approach, LOPA, then test interval, SIL verification, then we got SCV report, various reports required, then spurious trip, MTBF, MTTR, and general reports. So various reports are there, and it can be used via system, and it can be like Excel also I showed you. For LOPA, still we use but if you see here, just a minute, I cannot show you, it's hiding below, Ali. The SIF list, there are so many SIFs, you can see one item only, and then for each loop we need one sheet, so it becomes sometimes difficult to manage via Excel. So that's why some parts can be done in Excel quickly, but then we import the information in the software for demonstration and for control purpose. No, I cannot show the below sheets in the bottom, and everything is hidden by the. If you can move down. Bottom side, right? Where the screen is coming. Yeah, okay. If you see this, these are the various loops. So one by one, I can show you. Other loop, another SIF. It is each SIF if you see it. So this way you can use Excel also. If you can see, many are there, right? So just to show you, it is not we are only demonstrating to take software. We are saying it can be done in Excel also, but data is too much to be managed. So last part of the presentation we are moving. Then we have another question answer session. So gentlemen, keep ready with your questions and with your speaker, so as you can participate in the session. Last part. The case study is not a big one. What we are showing here, we're showing you only the result. Like brief, the project objective was identification of the gap between existing SIF and IEC 61511 client guideline requirements to maintain reduced corporate risk. Development and implementation of lifecycle program for existing and new SIFs. SIL classification, verification, testing, interval calculation, and preparation of SRS and STR reports. Subsequent suggested test plans to maintain the SIL at desired level. So the scope of this project was to carry out the following activities: preparation of master plan, SIL assessment, SIL verification, calculation of testing interval, preparation of testing plan, preparation of safety requirement specification, preparation of safety lifecycle management system. So here we have done the SIL classification, and plant 1, there are 4 units, capacity this, and number of PID is 80, and number of SIPs were 231. The total 2,324 SIPs were there in 6 plants. Number of units 51. With a barrel capacity 225,000. This was the capacity of the barrel per day. And EPC year was 1974, different years, 1983, 1999, 1999, and different years are there. Upgrade is also there. The number of PID is involved, and this. So major deliverables, what I said earlier, the same. Master plan for the safety life cycle management, list of all SIPs with assigned SIL, SIL assessment report, testing interval report, SIL verification report with collection sheet for each SIP, SRS and SPURI strip report, gap analysis report and recommendation for each SIP, software, PHA VAIL-PHA. So following stages were carried out to execute the project: preparation of master plan, carrying out SIL review, SIL verification and analysis, developing testing intervals, generation reports and recommendations. SIL assessment has been done to estimate the minimum risk reduction required against intolerable risk to bring to a tolerable region. This reduction has been evaluated in terms of SIL level. So here the result coming like from each plant: SIL 0, SIL 1, SIL 2, SIL 3, SIL 4. So SIL 0, 3 and 4 were 0. SIL 2 total 455 SIPs. SIL 1 1,311 and SIL 0 558. So general recommendation: all the operating unit of client facility has been undertaken during the SIL study. Most of SIP met the requirement of the standard. Recommendation has been provided against all SIP which are not meeting the requirement. Recommendation have been made to provide example to keep the flame scanner in operation during normal operation, as well as in addition to their use only during startup. SPURI strip rate has also been checked, and where it was higher than the target value, the recommendation have been provided. Redundancy check of all the components of the SIP have been performed, and wherever there is a gap have been highlighted to the client team. There are certain storage tanks on which only low level SIPs are present. On the contrary, similar type of tanks have high level SIPs as well. Both low and high SIPs should be available. Some PIDs that are not updated and need to be updated. HAZOP reports that are not either available nor updated should be updated. Implementation of these recommendations will reduce the risk level to corporate tolerable level or alarm level. So this is the SIL classification report in general, and this is SIL verification report. This SRS and STR report, and SIP lifecycle management document. The content standard. So basically, it brings to the last part of the presentation, and be ready for the question, gentlemen. Anyway, we are last part of the questions, so you can take your time to find the questions. Yeah, the question is: are you referring any failure data such as ORIDA?
Good evening. Am I audible?
Yeah. Yes, sir. Mr.
Yeah,
introduce yourself and ask question.
Yeah, myself, Aristides Raja. I was a former employee of ADNOC upstream drilling area. Right. And I am associated with oil and gas 18 years. And earlier I was a functional safety engineer, and now I don't have that certification. It got expired. Just to refresh my knowledge, there is a question came to my mind about ISA. We have referred ISA in the slides, ISA, but yes, it was 2002 version. Is it still, are we using, or is there any updates on ISA?
See, now the things are being overtaken by IEC, and ISA still can be referred in the comparison for both sides. IEC is better shape, but ISA is also under, so as the data can be compared in, or the configuration can be compared in the both institutes.
Okay, sir.
And the other side, yeah, we in a VAIL we do have ORIDA data built in.
Oh, that's great. That I saw it in the later slides.
Yeah, we have built in the VAIL.
Yeah. Thank you, sir. Thank you very much.
Thank you.
Yeah.
Next question, sir, from Mr. Drenda Kumar. Please unmute yourself, sir.
I think we have already explained the three methodologies, right? And like there is a risk graph, risk matrix, and LOPA. So this question is answered. Good, next question.
Assalamu alaikum. Good afternoon. My name is Shahryar and I have recently graduated from Institute of Space Technology as a materials engineer. My question was like, how does SIL address the challenges associated with human error, like in operation and maintenance, during operation and maintenance in safety critical systems?
See, the example what I was trying to show is like advert closing of the valve by operator error. So in that kind of emergency, what kind of safety instrument system is required to take care? So it means human error with respect to any kind of abnormality which can be caused by human error should be taken care by the plant ESD system. And that is a part and parcel of the SIL determination process. It is covered.
Yeah, right. Okay, thank you very much.
Yes, sir. Next question from Mr. Diman.
Diman Chatterjee. Okay. What are the checkpoints to be considered for SIL study for ICSS engineering during FEED and EPC stage? Mr. Chatterjee, can you please explain your question if you are available?
Yes, sir. Am I audible?
Yes.
Oh, thank you.
You're audible. Can you explain what you mean by ICSS?
Yeah, I'm talking about the integrated control system, BPCS plus SIS plus ESD and FGS.
Yes. See, if you see this, if you go to any ESD system, right, level, with integrated control system where some of the BPCS and some of the ESD should be working jointly, right? So in that scenario, you have a cause and effect chart, and you know your all transmitters or the manual intervention to initiate that shutdown. So those transmitters and their final elements as a part of cause and effect chart. So those are very much known and defined by the like a process and instrumentation control people. And then as you're preparing their IO list, input and output list, and you're controlling the interaction between BPCS and the ESD system, where the common or the individual. So it is very much focused and considered in the SIL assessment, I would say. But normally it is the understanding the ESD system should not be mixed up with BPCS system. BPCS is separate, DCS is separate, and ESD logic control is separate. However, in certain scenarios, both are found combined or together working in the older facilities. The new facilities, it is said that you should have a separate transmitter for the ESD system and separate transmitter for the BPCS, so as there is no mixing up of the signals and the final actions. So I know it is a very interesting topic, but I can explain up to this point now.
Okay.
Okay, sir.
Okay, thank you. Sir, I just have one more question,
Sure.
which I also put it in the chat box. If we have some non-standard items which don't have a defined PFD value from the OEM, like suppose say we have valves, the valve body itself. So in that case, how are we going to arrive at the PFD values to calculate the complete SIL level of the loop?
See, as per like personally, this is my own understanding. Wherever SIL verification is being done or testing intervals are being calculated based on URIDA data or EXIDA data, right? So as an example, I would say it is like going to a doctor without looking at your own condition. We will try to take the medicine as per like average human being of my age. It is basically not the right way. It is the only way, no option left. The basic thing is if I am operating my facilities last 20, 30, 40 years, And we should know what is the behavior of our ESD valve, blow-down valve, transmitters, which model of transmitter is giving more problematic signals and which are more reliable. And similarly on the ESD cards and BPCS cards. Now, if in many companies you will find that the own data is not gathered or not organized. So you are left to follow the data coming from the ORIDA and EXIDA, which is industry average data, which could be high or low as compared to your own plant facilities. So the answer to your question is it's better to check the failure rate or whenever you are testing your system, and then accordingly you can do SIL verification with your actual data. So now if you don't have actual data, then you can follow with the other industry average data, or if you don't have both, then something is better than nothing. At least you can start testing your ESD system 3 yearly on the shutdown to shutdown basis, and if you can make yourself assured that these loops are working when we need it, so it would be something good as a starting point.
Okay, thank you, sir.
Yes, sir.
Okay, next question, sir, from Mr. Sadhana Verma. Please read your question.
Is VAIL-PHA used as one? Yes, it's one program which has both HAZO and SIL workshop to the SRS as well. So that is the beauty of our program, and that's why we prefer if there's a big system. For small system, you can do in Excel also, but if you got loops over 1,000, and then it's better to use either VAIL-PHA or some other software of similar nature, so as the data can be organized and can be used effectively. Okay, next question.
Next.
Mr. Rizwan Hassan, if you can speak your question and introduce yourself also.
Yes, my query is, my name is Rizwanul Hassan and I'm from Intech Process Automation and currently based in Iraq. And my query is how a proof test interval is related with the SIL level of a SIF. So I have a couple of more questions. If you can please answer my question.
Because we are at the last stage and any question we will welcome, and we are sitting in the office and okay, we cross our time limit, but anyway, we can continue the question answer session till questions are finished.
Yep. And my second question is how what is the relation between PFD and age of equipment? Like old equipments tend to fail more often. So what is the relationship between these two?
See, I answer the second question first. There is no relationship as such between PFD and the age of the equipment. Like if equipment is well maintained, right, and if equipment is functioning properly, irrespective of its age, the PFD will be determined based on its failure rate. Like if a new equipment is having high failure rate because of the manufacturing problem, a maintenance problem, or some other constraint in the building or manufacturing of that particular ESD valve or solenoid valve, or a transmitter, or the transmitter, how transmitter was built, and signals and so on. So sometimes, depending on brand to brand, model to model, some new equipment may have more problem as compared to the good design of the old. So the answer is PFD is not relevant to age, but yes, age and number of tests and their PFD results or MTBF results would be important for the knowledge and for reliability analysis and reliability trend. But it does not mean that, like, if a facility is 50 years older now, it should have a higher PFD. The PFD should be within the acceptable range. Otherwise, we should replace that particular SIF, because it would not be safe to operate the plant with the SIF which does not have a desired reliability and which will not be able to function in case of any emergency situation at the plant, because we need to have these SIFs for safety and safe shutdown of the facilities. So that has to be kept in mind. Now, second, your question is the proof test. See, proof test is testing interval. If you see, a PFD is equal to half lambda T, where proof testing interval, failure rate, and desired SIL level, both are correlated and both should be managed. And when it comes to functional safety management, see, what is the probability of failure on demand? Like, if the probability of failure on demand is low, it means the functional safety of the system would be high. If the probability of failure on demand is high, it means, right, the process safety functional requirements are also high. So it both are correlated, and safety is going to risk, right? And the risk is related with the probability of failure and the consequence of failure, which are the consequences being taken from the severity, which is TML, EL is defined, and probability of failure is being matched by the initiating event as well as the IPL and condition modifiers. Okay, sir. Did I answer your question, Mr. Rizwan?
Yes. One final question. This tool, VAIL-PHA, can we use it as a functional safety management tool on a running facility, like to create the certificates for our safe after we done the proof test and this type of requirement?
Yeah, safety management aspects are global aspects, right? Our process safety management aspects are the global aspects, which carries various KPIs. Here, our focus is mainly how to manage your SIFs. So we are starting with HAZOP and doing SIL classification or determination, then SIL verification, then testing interval, then SRS, STR. So we are only focusing on the SIFs, and those are being managed by the VAIL-PHA and VAIL-PHA SIL modules.
Right.
Okay.
Thank you.
Thank you.
Next question, Mr. Sadek, please read your question. And then unmute yourself, sir.
Yeah.
My name is Sadek Belkacem. Can you hear me?
Yes, yes, yes.
My name is Sadek Belkacem. I'm from Sonatrach company. I'm talking to you from Algeria. So my first question is, when we verify the SIL of the SIF, we should only base on our PFD calculation, or there is another aspect should be taken into consideration?
See, if I can, my screen is, I think, visible to you. If I go back to my software, I want to see my software. Okay. If you see, one is without PFD. If you see risk matrix, this is there, and if you have risk graph, it's easy. Under risk graph, if you see, here we are not bringing PFD at all. PFD is becoming a function in the LOPA, which is semi-quantitative technique. But if we try to follow risk graph, it is considering, like if I add it here, the first aspect, consequence, moderate.
Sorry. I'm not talking about SIL classification. I'm talking about SIL verification.
Yeah, in SIL verification, PFD is the only way, because the formula-wise, if you see as per IEC standard, if I go back to my presentation or SIL verification again, I can go to test interval. In testing interval, there's some due to this presentation, the screen has gone down. Here, if you see, initiator, arbitrary voting, failure rate, right? Yes. Then we have to get this failure rate undetermined, then you can test interval, then test there. So here, the aspect is, just a minute, we have to match it with the PFD, right? So if I go next, SIL verification part, this is easy to part. We compare all this data with the PFD, because PFD is coming from the LOPA SIL target.
Because when it is mentioned in the IEC 61511 and 61508, there is another aspect should be taken into consideration as architectural constraint and systematic capability when it comes to SIL verification, not only the PFD calculation.
No, PFD is the ultimate target. If you see here, architecture voting is here, right? Manufacturer, initiator type, then failure rate. So all that, and then testing interval here. If you multiply that all, then selected test interval, what we try to follow in terms of hours, then RRF required, SIL level actual, right? Then you compare that all. So if you see here, when it comes to the SIL verification, the PFD and the failure rate, testing interval, voting, architecture voting, and the beta factors, all those are important.
And when we build our architecture,
here,
how can to balance between availability and the safety of the loop?
Yeah. So here at SIL verification level, we take the architecture voting.
Yeah, that's good. Okay. Just another question, please.
Okay.
The second question is about what is the difference between MTTR and NRC, mean time to restoration and mean repair time. Is there any difference between them?
See, there are two things. MTBF is clear, mean time between failure.
Not MTBF, MTTR, mean time to restoration and mean repair time.
Yeah, both. If you see that, I had a presentation, just a minute. I'm going back to that. See here, MTTR is mean the repair refer to the amount of time required to repair a system and restore in its full functionality. MTTR clock starts ticking when the repair starts and goes on until operations are restored. This includes repair time, testing period, and return to the normal operation condition.
Yes. Third question, please. Should the fire and gas system have SIL rating?
You have to repeat the question, sorry.
Should fire and gas system have SIL rating?
See, fire and gas, normally they say it should meet SIL 2 criteria or minimum SIL 1 criteria. The fire and gas system, there are two kinds of fire and gas. One is only given alarm, and other one is linked with the ESD system directly, right, sir? So, for example, take the case of turbine enclosure. There is a fire and gas detectors which are linked with the gas at turbine shutdown. So, in that area, it is important and it is linked with the SIL, because if any detector is detecting gas leakage or flame or smoke, it would be shutting down the facility. So SIL classification is important.
Yes.
Other one is a normal fire and gas system which at the facilities which giving us alarm at a standby console, and nobody is taking care of that. So for that, if you are not carrying that fire and gas detection system, it is not being calibrated timely, not being tested, then SIL classification may not be required, because you are not using that system anyway. It is always false alarms and everything is being bypassed. So it has to be seen as a normal company philosophy. Otherwise, SIL classification and verification very much important for the fire and gas detection system.
Thank you. Please, the last question, please. What are the main aspects should be taken into consideration in order to implement our functional safety management system within the organization in order to avoid systematic failure that can impact our SIL?
See, it's a normal culture. For example, three techniques are normally we refer for planning of inspection and maintenance activities. The RBI for static equipment, RCM for the rotating electrical instrumentation system, and SIL for the SIPs, right? So what the purpose of these three techniques is, what should be my frequency of inspection, condition monitoring, or functional testing of the SIPs. So these three technologies help you to determine the interval so as you can test your equipment hardware during shutdown, before shutdown, on stream. So in any company, there should be inspection and maintenance program, preventive maintenance program, or condition monitoring program, or functional testing program. So for that reason, these techniques are useful. But now, if company or any company culture does not follow these technologies and they're going on time-based, or they have their own way of making sure these systems are working, so they can go by their own way as well.
Thank you, sir. I appreciate it. Thank you.
Thank you. Another question? Okay, sir. Thank you very much, gentlemen, for participating. We also enjoyed. So we'll be making the next sessions also same as interactive, so as we can also see and take feedback from the participants of the session. So thank you very much for your time and look forward to meeting you in our next webinar.